Chapter 5, we're going to discuss probably one of the most important topics in finance, which is the time value of money. It's the mathematics of decision making. So we're going to take our time. It'll be broken into two parts because there's a lot of material, and we'll kind of go from there, I guess. So let's go ahead and get started. Again, we already mentioned this in previous chapters that essentially we're talking about the costs and benefits of projects and investments is what financial decision making is all about. The challenge with this is that it's in different time frames, that all financial decision making is based on some prediction of a cash flow that's going to happen in the future. The time value of money, this mathematical model, allows us to make comparisons from different periods of time so that we can analyze and process this data to make our financial decisions. So here's an example. Which would you rather have? Would you rather have $1,000 today or $1,100 1 year from now? And the question obviously is, well, what would you do? Which would you rather have? Well, there's more information that we really need to know to understand, to get the right answer, if you will. We need to know something about interest rates. We need to know something about the riskiness or the uncertainty of the payment streams. So there's a lot more information. It's not as straightforward as just pick one. We have to incorporate some more information. So here we have a company, right? We have the opportunity to spend some money today. We could spend $15,000 today, and that's going to give us $17,000 spread out over the next 5 years. So as you can see here, obviously this 5-year window here all adds up to $17,000. And the question again is this a wise investment? Now here's what we know about life. I mean, you can test this out. Ask your parents, when you were my age, when you were 20 years old, when you were 25 years old, what was your income like compared to now? Maybe they don't want to tell you how much they make now, but just ask them, is there a difference? Do you know what your grandparents made when they got married way back when? And the point is that the dollar buys different things at different times of history. It buys a lot less stuff today than it used to buy a long time ago. So how we would focus this and create this analysis then is we say we can use this process as something called a timeline. Here's my initial investment of $15,000. You see it's a negative number. And then here are the cash receipts for the next 5 years. How can we analyze this? Well, that's the process that we're going to go through. We're going to be moving money both forwards in time and backwards in time. Moving money forwards is referred to as compounding. We want to actually ask an investment kind of a question. If I were to invest these cash flows over time, how much would I have when I get out here? The other question in time is the present value, or the discounting question. If I could get these monies in the future, what would I be willing to pay for that? What is their value to me? And this is a concept throughout the whole thing. We can calculate, oops, I'm sorry, went ahead. You know what the present value is. Let me get a pointer here. So you know that this thing costs $15,000. But what is it worth? This is what present value answers. What is the value? If you could hold this in your hand today, in today's currency, what would it be worth? And that is the process we're going to be working through. I'd mentioned, make sure you need to understand that we're going to be using a financial an electronic spreadsheet on a computer, obviously. We have to tell the instrument, whether it be a calculator or a spreadsheet or whatever, we have to tell this this instrument whether the cash flows are positive cash flows, that is, we're receiving money, or whether we're investing money or putting money out of our pocket in somewhere else. So we have to tell them what the signs of the cash flows are. There are three basic patterns that we're going to look at. We're going to look at single amounts or lump sums. We're going to look at what are referred to as an annuity. An annuity is a level periodic stream of cash flow. So it is an equal payment for a certain period of time. And then we're going to also talk about something called a mixed stream. And a mixed stream really is a corporate type of an application. It is a forecasted or a predicted cash flow stream into the future, but those cash flows are not constant. Just to kind of give you a little segue into that, I mean, if you think about the income of a company, right, what is their net income? Is that net income constant year after year after year after year? And the answer is obviously no, it's uneven. We've talked about calculating the free cash flows of companies. Those free cash flows, as you calculated for the company in the web exercise, they are not even or equal year after year. So we have to have a method of dealing with these unequal cash flow streams. So let's start thinking about moving forward then. We want to talk about calculating the investment value or the future value of an asset that you invest today. We're going to be utilizing a concept called compound interest. Compound interest is when you earn interest on interest. In fact, that's the phrase that kind of describes it. Interest earning interest is compound interest. Principal, then, is the amount of money that is invested. It's the amount that's put forward. There are some terms that we need to come across and deal with in these time value problems. And again, depending on the kind of financial instrument that you're using, these could be different from time to time. But in general, they're the same basic acronyms, if you will. PV is present value. It's also the beginning amount. The present value will always be negative. I is the interest rate. Sometimes it's going to be IY, interest rate per year. Sometimes in the textbooks, I's will be R's for returns. FV, obviously, is future value. It's the amount that comes in the outward in the future. N is the number of years. A is the annuity. Sometimes you also see it listed as payment. But this is the amount of the equal payment that you receive over a certain period of time. And of course, we can calculate the present value of an annuity stream and the future value of an annuity stream. M is a complicating variable that helps us understand that different investments pay interest at different times. M also equals P divided by Y in some financial calculators. That refers to the periods per year. How many times per year do you calculate interest? So here we have an example. Fred puts $100 in a savings account. It earns 8%. It's going to compound annually, and we'd like to know how much will he have in this account at the end of 1 year. The future value, then, how you calculate that is you take the present value, and we're going to multiply it by our formula to give us this is called an interest factor, tell us what we'll have in the future. We'll have $108. Now, if Fred leaves that money in there for one more year, how much would he have at the end of the second year? Well, you put the $100 in the first year, and of course, this is the first year's interest, and then this interest factor calculates interest for the second year. So in the 2 years, we're going to end up with $116.64. the difference, again, obviously it's 8 and 8, 16, that additional 64 cents comes from interest that is compounding. Now we'd like to have an easier formula. So here's our formula. If you wanted to do this by hand, you'll notice that it has an exponent. Time value is all about the exponential growth of money. In this case, R, we're going to use R for interest rate here. But again, the calculation is the same, except now we're using an exponent. So Jane puts $800 in a savings account that pays at 6%. Interest is compounded annually. How much money we would have at the end of 5 years? Well, here's our formula. You'll see it's $1,070.58. Now we have a finance spreadsheet that I've provided for you. If you look under this, there's something called time value. If you go open that spreadsheet, it's time value, and you'll find this spreadsheet available for you to enter data. Now we've talked about the spreadsheet before. Of course, you know that the yellow boxes are where you put the data. So we need to put the data in here. Negative 800 is present value. Again, why is it in there as negative? Because it's an investment. It's an outflow of cash. 6% is the interest rate, 5 is years, and M, or the compounding frequency, is 1. And of course, you see we get our answer here of $1,070.58. What about present value? Present value is pulling money backwards. We think we're going to get some money in the future, and we would like to find out what it would be worth in today's money. This process is referred to as discounting the cash flows. We also have a lot of other synonyms, if you will, for discount rate. That is the interest that we use. Could be opportunity cost, the discount rate, the required return, the cost of capital, growth rate, inflation. There's a variety of names that discuss or represent the growth of funds over time. So Paul here has an opportunity. He's going to get $300 1 year from now. If he could earn 6% on his investments, what's the most he'd be willing to pay to get this investment? Again, our formula, we can calculate through the formula if we want. We need to then know that the present value here is $283.02. Again, if we assume inflation equals 6%, what does this imply? Well, what this implies, obviously, is that $283.02 today will buy the same amount of stuff as $300 1 year from now. So the prices of goods are going to go up. So everything that you had this year, if it totaled $283.02, in 365 days, it's going to cost $300. So what does our formula? Again, if you want to work on the formula, the future value now is divided by this compounding interest factor. So let's move on and look at an example. Pam wants to find the present value of $1,700 that she's going to receive in 8 years. And she has an opportunity cost of 8%. Using the spreadsheet, the future value is $1,700. That's what I'm going to receive in the future. 8% interest, 8 years is the investment time frame. 1 is the compounding frequency. And of course, you can see that the answer is $918.46. So again, that's the value. That's what you think it's worth in today's money. And of course, you wouldn't spend $1 more. You wouldn't spend a penny more to get this $1,700 than that amount. That's the maximum that you'd pay. So now let's change gears just slightly. Instead of talking about a lump sum, we're going to talk about a periodic sum. an amount of money, a cash flow that comes in equal amounts for certain periods of time. Now there's two ways to look at this. If you think about investing, today is time zero. So the question is, when do you put the money in the bank if you're investing? Do you put the money in today, or do you put the money in at the end of the year? From an investment perspective, you're thinking about an individual, I think it's obvious that you start money, you put investments in today, you don't wait till the end of the time frame. But if you think about corporations, when do they get money? Do they get their money at the beginning of the period, or do they get their money totaled at the end of the period? And the answer obviously is at the end of the period. And additionally, when do you make loan payments? When you buy a car and you borrow money, do you make a payment that day, or do you wait till the end of the month to do that? That is the concept of annuities, and there's two kinds. An ordinary annuity happens at the end of each period. And this is the norm, by the way. If you want the other kind of an annuity, which is an annuity due, that happens at the beginning of each period, you have to tell the instrument, whether it be a financial calculator or whether it be a computer, you have to tell it whether it's that you want to switch from an ordinary annuity to an annuity due. That's just the way the formulas, etc., set up in the mechanisms as we move forward in this analysis. So here we have two examples, two annuities. We can we're going to receive these annuities. So I can get $1,000 a year for the next 5 years, and I can start to get that $1,000 at the end of this year. So at the end I'll have $5,000. Or I can receive my $1,000 today and get my 5 payments, so that within 5 years I'll get 5 payments of $5,000. Are these equal cash flows? They both total $5,000, but they're not the same. Why aren't they the same? Well, these cash flows are identical. They all happen the same year. But these two cash flows are the ones that make the big difference. One occurs today and one occurs in 5 years. That is going to have an influence on the values that we calculate, whether they are present values or whether they're future values. So you can calculate this, and it's very complicated. I think it's a complicated formula, but you can obviously calculate this by hand if you want to. It gives you an idea of how the very nature of this of calculating the exponents. And of course, if you want to solve for any of the variables in between, now we have to go and we have to start talking about some calculus. We have to use some logarithms to calculate some of these numbers. So here we go. We have this cash flow stream. It's $1,000. 7% is the interest rate that we choose for 5 years. So what is the future value if I'm investing? The future value of the annuity is listed down below here. It's $5,750. Now, if you want to put your video on pause, input these into the spreadsheet and see if you can get this 5750 number. The process here is actually very mechanical. Now, what you have to remember, though, this is the only data you need. So we were doing some present value and future value, so you have to delete those from up above. What about the present value of an ordinary annuity? Right? We want to do this, bring these back in using ordinary annuity concepts. So the cash flow is going to occur at the end of the year. So the Braden Company here is a small producer, right? The annuity that they're going to $700 is what they're going to receive at the end of 5 years from this investment. They require a minimum of 8% to invest their money. So what should they be willing to pay to buy this investment? Or what is its value in today's dollars? 8% is the interest, 5% years. We're still talking about one compounding period per year. And now the payment period, the payment is $700. Notice it's a positive amount because I'm going to be receiving it. The value in today's money, this is $27.94. That's what we'd be willing to pay today to get $700 a year for 5 years. We can calculate this present value. Obviously, we can do this if we really wanted to for an annuity due. You see, it just adds a little extra onto the end here, complicating the formula just even a little bit more. Again, I'm not concerned about the formulas. You're not going to have to memorize these. We have a computer that's going to help us do the calculations. So we want to choose between whether this should be an ordinary annuity or an annuity due, right? That last example, 7% for 5 years, $1,000 is what we're investing. How much will be there in the future? Well, if, as you see here, I change this ordinary annuity from a yes to a no. So this is now, is this an ordinary annuity? The answer is no, this is annuity due. That's $61.53. Oops. Sorry, pushed the wrong button. $61.53 is that future value, right? If we go back to where we were, you'll see that it is $57.50 was the future value if we use the ordinary annuity. So $57.50 is the ordinary annuity. The annuity due is $61.53. So it's obviously what? It's more money. And that's what we'll find in general, right? That annuity due, if you're speaking of investing, annuities due will have greater future amounts than current amounts. And likewise, annuities due will have less value when you're talking about present values of an annuity. Oops, I think we did this one. Oops. Oh, and here's just that other example of the present value. See that it's $3,018 is the present value relative to the previous slide that was, excuse me, I think I might have misspoke, which was $27.94. So it's a more negative number, if you will. It's going to cost us more if we're talking about present values of an annuity due compared to an ordinary annuity due. And as you see, that's the end of part 1. We'll move on to part 2 next.